All right, for the first step of our lab, we're going to create a new file. So I'm going to go up to File, New, or you can use Control N. We're going to get a dialog box for New Project. I'm going to name the project. The location should already be set up for you. So we're going to give it a name. The first I'm going to put is Lab 1, followed by our last name, then our first name, then the type of processor, which in this case it's 24QBB. I'm going to hit Create. Nothing appears to happen. You give it a moment. You're going to get the Add Device dialog pop-up box. So we're going to go to Controllers, press the little arrow to open up the tree. We want a Micro 850, open that tree. We want the LC50, open that tree. And we're going to look for the 24QBB. Now this entire number, you'll want to write that down, because it may come up in a question. Once we have that, we're going to press Select, and then we're going to add it to the project. And we can see that it's completely set up. Our project organizer has the programs and global variables and not much more. We'll move on to the next step. Now, before we begin our actual programming, we want to identify and name some of the I/O that are being used. So on the lab form, you should have the I/O set up and drawn. So we're going to go to our global variables because the I/O is always considered to be global. I'm going to double click on that and let it open up. And we get a full page listing everything that is available on that particular model. The first rows are going to be digital outputs, saying DO. So we have from DO, digital out 00 through to 09. So that would mean there are 10. And on the digital inputs, we go from digital input 00 through to digital input 13, which means we have a total of 14 available to us. So let's first put in our inputs because they're on the left side of our paper and it's probably easier to work with. And the first one says we're going to be using digital input 01. So we're not using this one here. We're going to go to the second one. And this has already been assigned, but we're going to give it an alias so that we know what it's for. And in this case, it's going to be our system start PB for push button. The next one we're going to use is we're going to go down to input, digital input 3, and we're going to put stop PB, and then we're going to use 4 and 5. Number 4 will be forward limit switch, or just forward limit is fine. And the next one is 05, and it is reverse limit. You're going to do the same thing for the digital outputs, which are found on the other side and up near the top. Now that we have assigned all our I/O, we're going to look at starting to do our program. So we're going to have to go over to Programs, and we're going to right-click. We're going to Add, and we're going to add a new ladder diagram. At the moment, it has just prog1. So we can double-click and open it. And we can also right-click on it and go down where it says Rename. And we're going to call this Lab 1. And I'll put my initials. Oh. Must use no spaces. Bad habit on my part. Okay, so I'm going to call that ladder 1 underscore etc. Okay, now the next part here, this is our first blank run. There's a blue box on the top. If you want to be successful, we're going to put information here for the next person. So we're going to double click until we have a flashing cursor. And I'm going to call this my lab 1. And I'm going to put my name so everyone knows who's done it. I can press the enter key. And then you should put a description of the run. The first, and always proofread it, that's always a good thing. The first run shall be a CLN run to latch up CR1. And this should be taken from your paperwork, and it tells the intent. When you get a little more sophisticated, you're going to go back and edit it to list the inputs and outputs that you've used. So once you've completed your commentary on it, you can then go and proceed to write the actual logic. So now we're going to start populating the contacts and instructions on the run itself. There's two ways you can do this. You can do simply drag all the parts you want and then name them after, or you can do them one at a time. So to do this, we're going to look at our, first we're going to look at our menu bar and make sure we're either on favorites or bit. Bit has a few more options with specifically to writing and reading from one bit or one address. So we're going to leave it on the bit, and we're going to start off with taking this one, which is a normally open contact. And if I'm looking at the logic, I'm going to need another one in series. And I'm going to drag one over here for a moment. It doesn't really belong, but we'll fix that in a second. And then we're going to get this one here, which is our OTE or direct coil output. And I don't have to go all the way over to the right. I just have to go where the plus sign is and let go. And it's now been put on the right hand side. Now I've got two symbols here. This one is for a brand new rung, and this is for a branch. So I'm going to grab the branch and I'm going to put part of it there. And you'll notice it automatically jumps around. Now sometimes you'll want to get two and you end up getting these strange configurations. So what I find the easiest is to just put the branch in first and then take the contact you want to move and drop it in where you belong. And that's what we want for our particular program. Working with branches can be tricky, so take your time, it's not a race. Now the last thing we've got to do is to get rid of these yellow attention triangles. They are telling us we're not done yet. If I were to attempt to build, I'm going to go up to my device, and building is a method of verifying that the program is ready to download into a processor. And it's going to check for fatal errors. And if it's fatal errors, it's going to say, no, you can't do that. And here down on the bottom is our report. I'm going to give that a little bit more room. And I have these red X's of death. You cannot do anything with this. You have to fix these errors. It will not let you pass go. You can't collect $200, etc., etc. So what we're going to do is we're going to go back up to our program, to our ladder, and each of these yellow attention triangles, I can right click on them, and it's going to bring up something called the variable selector. So I'm going to click on that, and we've seen the big version of it when we did all of our aliases. So I just need to scroll up until I find the alias that I'm looking for. So the first one I want is my stop push button. And I hit OK. I highlight, hit OK, and there it is done. The second way you can do this is there's an invisible blue box that will pop up when you move the mouse. if I were to double click on that, it's going to give me a little drop down. Now this can be a little tricky if you don't know the name of it. It's not too bad for us right now because we're looking for embedded module, DI, digital input, yeah, and I'm looking for 00. So I'm going to click on that, press enter or click. Oh, I made a mistake. That's supposed to be on the bottom one. I can't drag and drop it, unfortunately. I just moved the whole thing. But I can move the contact. So now I've actually reversed positions. So I'm going to do the same thing again. So zip down until I get to the 01 for our start. And notice that here it's populated with our alias. It appears I did not properly name this. So let's go over here and give that the same name. This is an output. This is an input. Be careful when you're selecting. The other way you can do it is if you continue to scroll down, you should at some point begin to see some of the different aliases that you populated. So there should be one that says CR. IO. Nope, it's not coming up. All right, we'll just do it the other way. Maybe I missed that one. Digital out 00. Yep, press enter. Oh, and it does appear. Perfect. Okay, I'll accept that answer. I'll go over to the other side, do the same thing. We want digital output 00. Notice how it comes up first because it's an output. And it's our control relay, and that's basically the entire run complete. Now carrying on part 1 of the lab, under conveyor run, we are to add an additional run of logic. So what we're going to do is we're going to go up to the top where it says run, and we're going to just drop that right here. And it's now highlighted blue, tell us that's what we're going to do. And we're going to populate this, and then we're going to put the commentary after we follow the instructions. So it says I'm to take a new one where the digital output 00 is a normally open direct contact next to the left rail. So they're looking for a normally open contact here. And since I know its address, I'm going to take care of that right now. Zippity-doo-dah, output, and they want output 0. There it goes. Then, in series with the first instruction, add another normally open contact. And it's going to be the LS, the limit switch 1 that we had. So let's see if we can find that the easy way. All the way to the bottom. No, stop, no, doesn't seem to be there. Okay, we'll go to the right click, variable selector. And we're looking for limit switch 1. So I'm going to scroll up. Judging by the different text, I'm assuming that the forward is the limit switch 1. So we're going to use that. And it says use DI04. So that's what we have. Okay. Drag a coil instruction to the right-hand side using the alias conveyor. Okay, so we're going to drag that, and it's going to populate over here. And we're going to go right-click, variable selector. I'm looking for an output. And I have one conveyor starter, which is the one they're looking for. I'm going to go OK. And then we're going to drag a branch around the first limit switch. So we're going to take our branch, put it there, and it's populated right around it. Excellent. And insert a direct contact instruction with the address of the output on run 2. Okay, so this is our conveyor starter. So we're going to take this, and we're looking for digital output 3. DI, DO3. And it now has a self-sealing bit from the forward limit switch. Amend your program by inserting another direct contact with the alias of limit switch 2. Place this in series with limit switch 1. So we're going to grab another contact, throw that there, give it the address, and we're looking for limit switch 1. So this will be limit switch 2. So I'm going to go and right click, variable selector, reverse limit, okay, hit Oakley Dokley. So amend this program so now you have 3 normally open input instructions are ANDed, and 2 of them are ORed or latched. Include all comments and instruction on the run. So now we have to type in here a description of what the run does. I don't need to repeat my name because I know who did the programming. So when the control relay is true and the forward limit switch, etc. So part 2, we're going to add one more rung. So we'll start with our new rung here. Drag and drop. Excellent. And it says what they want to do is they want to put a pilot light that says the machine has stopped. So I'm going to grab my pilot light first, and it's going to send it way over off to the right. So now I can insert a contact ahead of it. And since I know this is my pilot light, I'm going to hit my variable select by right-clicking. I have more than one screen, so it's kind of popped off the screen. I'll bring it back for you. There we go. Okay, and we're going to look for an output of some sort that says, oh, null stop pilot light. Okie doke. And over here, they want this controlled by, to output a pilot light field device, place direct coil, where digital output 0 is the contact to the next rail. So that's basically this address here. Now one thing you can do, if your life is a little bit, you can highlight this contact, and I should be able to right click, go copy, and then go paste. Try that again, copy, paste, and there it is. So I have my same address just by copying and pasting it. You can also should be able to copy the instruction and then paste it. Paste the entire instruction to save yourself a little bit of extra work. If you don't require it, of course, you have it highlighted. Just hit the cut or delete, and it will remove it. So now I have this going to that. Now, once I've done all this, again, I need to put some commentary in there. But before you try it, we're going to go up to a device again. We're going to press build, and we're going to verify that it'll actually work. And I got a successful build with nothing failed, and I'm up to date. So at this point, we can then download the program to the processor. And once you've done the build, you may notice that it leaves the ladder logic screen and takes you to the main Micro 850 homepage. And that's so that you can then set up a connection path. To do that, we go over here into the corner. Now, I'm not working on a trainer, so for me it's going to be a little bit difficult. I could use the simulator, but I would have to change the process that I've used. And that's not that difficult. I go back to my device, and there's a function that says change the controller. So I would click that and I would simply change the controller. Under normal circumstances, I want to try to connect. So I would hit the connect button, and that should call up an internal app known as RS Links. And it will say RS Who, or connection browser. And there you see it says RS Links Classic. And it's going to show the different Ethernet, USB, all the different drivers that have been installed with this over time. Because every time you try to connect to a different processor, you may need to use a different method. You might need USB, you might need Ethernet. Some of the older processors would use other various forms, things called data highway plus, and all the rest of it. And there's also Modbus and Profibus. There's a lot of different ways that we can now communicate between them. So I'm going to pick one of them, and I'm going to hit the plus sign, and it's going to poll to try to find them. These are the last devices that it successfully talked to. As soon as I see the red X, those IP addresses no longer apply. So I'm going to open up my second one to see if I can find it. For you in the lab, you'll find on the very bottom there'll be USB. You will click on the USB and it will show you only the single processor you're talking to. When you find one successfully, then you can connect to it. This OK will be highlighted. Press OK. And then you're going to use one of these two. You're going to use the download button. Just cancel that for a second. You're going to use the download button. You are the cloud. You have all the knowledge. You're passing it down to the processor.